Okay, before we start this second topic, it's going to be very important that your calculator, whichever one you're using, is in degree mode. So most calculators will default to this. If you're using one of the TI 83 or 84 graphing calculators, it defaults into what's called radian mode, just a different way of measuring angles. So if you have one of those graphing calculators, please press the mode button now and make sure degree is highlighted, then press enter. Okay, any other scientific calculator, you're just going to take a look at the screen, the LCD screen, and make sure there's either a little letter D on there or it says DEG, something along those lines will let you know it's in degree mode. Okay, so here we're going to deal with missing sides of right triangles, and more specifically, we're going to use the angles to help us out. So that first example asks us to label the following right triangles using the words adjacent, opposite, and hypotenuse given the reference angle of B. And this is something we talked about in the last video. So I have a reference angle, and there's a little symbol inside this triangle that says this is theta, that Greek letter denoted or used to denote angles. So there's the reference point I'm looking at. Now, the easiest side to label is always going to be the hypotenuse. It's always going to be the one across from that right angle. It helps narrow down our choices a bit. The opposite side to angle theta or angle B is going to be the one furthest away from it. That's not the hypotenuse. So the only choice I have is up here for side B. Okay, which means my only option left is my adjacent side. Now I'm using the shortened version of, so the first three letters of each word in order to label this triangle. Okay, we're going to do this again for letter B. Okay, so I've got a right angle triangle again. I need to have that. I don't have letters like A, C, and B, but I do have an angle of theta. Okay, so we're going to label the hypotenuse first. Again, always the one opposite the right angle. Now I'm going to look back at this angle of theta. The side length that is opposite to it is going to be the one furthest away, and the only one left is going to be our adjacent. Okay, I know it seems kind of trivial, but if we can't label that triangle, all of the things that we're going to talk about that follow, they aren't going to work. So I need to be able to do this. Down below there are some practice ones, so again, I'll just leave it there for a second. If you want to pause the video, try those ones on your own. And here is the answer key. Now they're only using the first letter of each word, just so you know O is opposite, A is adjacent, H is hypotenuse. So you can go ahead and try those and come back to the answer key when you've tried them out. If we continue on, sometimes we're only given one angle and one side and asked to find another side. So remember when we talked about it in the last video, we had the Pythagorean theorem, which gave us two sides. Sometimes we don't get two sides. Now, something you would have learned in a previous math course is what sine, cosine, and tangent are. Now, all they are relationships between two sides in a right angle triangle. Notice the symbol of theta is in each of them, which means I'm going to be working with an angle. And it's always going to be an angle and two sides to complete this ratio. So there's three things that could possibly go in there. As long as I have two of them, either one angle and one side, I could find the other missing side. If I have two sides, I can find the angle. Okay, and something we're going to work on. So we're going to use these ratios to figure out the missing pieces of information. Now on the side, you're going to notice some tips, things to remember. So please, again, make sure you're in degree mode, and there's a little calculator tip on the side which you can read. So in order to find a side, we're going to use the given angle, label the triangle, and then determine the trig ratio that we have to use. So for this very first one, we're going to label this triangle first. I have an angle of 26 degrees. My hypotenuse is labeled for me, 16 centimeters. That's the side opposite the right angle, which means side length denoted by x has to be my adjacent side. The one across from it, it's my opposite, which I don't really need in this case. So we're going to determine which ratio I have to use when I have an adjacent side and a hypotenuse. And the only one that's going to work for us is what's called cosine. Okay, so the cosine of some angle theta is equal to the adjacent side over the hypotenuse. I need three things I got to put in there. So we'll go ahead and start filling stuff in. We have an angle, 26 degrees. The adjacent side, I don't know it, it's x. The hypotenuse is 16. Okay, when I have something that looks like this, it's important to remember that the cosine or the sine or the tangent of a number or of an angle is just a number. There really isn't anything special about it. So what I can do is divide that number by 1. And if I can do that, I now have two fractions that are equal to one another. This is what's called a proportion. Okay, and what we can do is multiply the two numbers that are diagonally across from one another, divide by the one that's left over, and that will take us straight to our answer. I call this in my classes the fish method, because if you've done it right, you should be able to draw a little fish, and its tail will take you right to the answer. So in our calculators, we're going to put in 16 multiplied by the cosine of 26, making sure we're in degree mode. Then our answer, x, is going to be the missing side length of that triangle. And to the nearest tenth, it's going to be 14.4, and it's going to be centimeters. Okay, we're going to take a look at another one. So for B, we again have to label the triangle in order to figure out which side lengths we're using. So 48 is my angle, my hypotenuse is across from the right angle, my opposite is x, and my adjacent is 12. Now, if I'm using the adjacent and the opposite side, I don't want to use the hypotenuse. There's nothing there for me. It won't help. So opposite and adjacent, the relationship between those two is called tangent. So the tangent of theta is equal to opposite over adjacent. Now again, we're going to fill in all the stuff we know. So the tangent of 48 degrees is equal to opposite is x, adjacent is 12. Now once again, just like we said in the last example, tangent of 48 is just a number, nothing else special about it. Now any number I can divide by 1 and not change a thing. So we're in the same scenario as before. We'll multiply our diagonals, divide by what's left, it'll take us straight to our answer. We got our happy little fish, we're good to go. Take 12, multiply it by the tangent of 48 degrees, and to the nearest tenth, you get 13.3, and do we have centimeters again? Meters this time. And there is our final answer for that side length. Okay, if the pattern is true, the next one should give me a sine ratio. So let's go ahead and label the triangle and see what we have to work with. Our hypotenuse is x, the opposite side is 9, the adjacent is the one I don't need, it won't help. So if I'm going to do opposite and hypotenuse, that is absolutely the sine ratio. So the sine of theta is opposite over hypotenuse. We'll fill in all the stuff we know. So the sine of 55 degrees is equal to 9 meters divided by x. And now we've run into a situation we haven't dealt with yet. My unknown side length is on the bottom of this fraction, which doesn't change a thing. It just changes the order we do things in the calculator. Now, just like before, sine of an angle is just a number. Divide that number by 1. We set up our proportion perfectly. Now we just got to figure out which direction to do things in. Now we're always going to multiply the two numbers that are diagonal from each other. I can't use x and sine 55 because I don't know what x is. So I got to go 9 and 1. So I'm going to multiply those together, divide by the sine of 55, and my fish's tail takes me straight to my answer of x. So we're going to go 9 multiplied by 1, and then divide it by sine 55. And to the nearest tenth, it looks like I'm going to actually get 11.0, and my units of meters is equal to x. Okay, and there you have it. There's how we use those three trig functions to help us find a side. Now it's much, much shorter than using the Pythagorean theorem, but I also agree that it's something new and it's not something you're used to. So it is going to take some practice to get used to that. Okay, so down below, again, are some that you can try out on your own, which I will. There are 6 right there, so I'll leave it there for a second, and I'll scroll down to get you that answer key. Oh, I lied, there's 9. So there's a couple more. And there are the answers. Okay, so again, if you're stuck, rewatch a section of this video to see how we set them up and try those ones out on your own. Come back in the next video, we're going to be determining angles. So all we've done so far is found side lengths. In the next video, we're going to find angles. So please come back and check that one out.